In April 2026, the metrics we use to define human genius were recalculated by a machine. OpenAI's GPT-5.5 Pro version underwent the Mensa Norway visual logic test and returned a score of 145. For context, the threshold to join Mensa is 130. A score of 145 belongs to the top 0.1. Researchers discovered that image generation models already build a map of physics, depth, and lighting within their internal code. To draw a realistic room, the AI must already understand the volume and orientation of every object within it. DeepMind tapped into this by using RGB parameters. They trained the model to represent 3D surface data as simple colors, assigning pink for one direction and green for another. This method allowed a single generative model to outperform dedicated vision software like SAM3 in segmenting objects and estimating the depth of a room. We have built a machine with the logic of a genius and the eyes of a master architect, yet it remains tethered to massive, energy-hungry server farms in the cloud. Sustaining this level of intelligence requires an immense financial commitment. Alphabet recently pledged $40 billion to the AI startup Anthropic to secure its future. This deal functions as a circular trade. Google provides capital to Anthropic, which uses that money to pay for Google's TPU cloud servers. The physical requirements are vast, guaranteeing Anthropic 5 gigawatts of compute capacity, enough to power 750,000 households. While American giants build these expensive, closed ecosystems, China's DeepSeek V4 is taking a different path. It is a 1.6 trillion parameter open-source model designed to provide high-level intelligence at roughly 1/6 the cost of its Western competitors. The cloud has become a massive, energy-intensive bottleneck, forcing the industry to look for a more efficient frontier. This search has led to Edge AI, where intelligence is moved out of the data center and into the local hardware we use every day. Apple signaled this transition by appointing John Turnus, a veteran hardware engineer, to lead the company. His task is to embed advanced AI models directly into the silicon of consumer devices. In Japan, the government is backing the shift with a $6.3 billion national initiative aimed at integrating large-scale AI with the country's manufacturing strengths. A consortium, including SoftBank, Sony, and Honda, is developing a trillion-parameter physical AI. This system is being built specifically to handle the high-stakes logic required for autonomous driving and heavy industrial robotics. For the average home, Tuya's new Hey Tuya platform allows AI agents to take active control of physical environments, managing energy usage and security without requiring the user to write any code. The digital brain has finally found a physical body, changing how our homes and factories respond to the world around them. As AI moves from the screen into the physical world, the impact on the individual worker is becoming clearer. A new report from Epic AI and Ipsos outlines the current state of adoption. While half of the population now uses AI tools, only 6% use them daily. Most people still view these systems as simple search assistants rather than tools for deep productivity. This chart highlights the divide in how AI is used at work. With free tools, only 38% of the tasks are work-related. That number rises to 58% for self-paid subscriptions and reaches 76% once a company provides full corporate integration. The speed of the AI revolution is currently being dictated by how quickly corporations are willing to invest in deploying these systems to their staff. We have entered the era of the human pilot. In this landscape, the advantage goes to workers who direct these high-level systems rather than competing against them. Employees are using AI to automate repetitive administrative tasks, freeing them to develop professional capabilities that were previously out of reach. The machine has already proven it can think like a genius. The next stage of the story depends on how well we can lead it.